Welcome to MH class. Today we'll discuss about the linear programming, how to solve the linear programming problems. So graphical method of solving linear programming or solving LPP. Okay, let's see. If a problem contains only two variables, then we can solve the given problems by graphical method. Okay, so if it is containing only two variables, then we can solve it by graphical method to solve the linear programming problem, LPP. Corner point method. How to use the corner point method? See, this method is based on the fundamental extreme point. We will find out the extreme point, fundamental extreme point of the theorem. Okay, how to formulate the system of the linear inequalities involving two variables x and y mathematically. So with the help of the corner method, we will find out the values of x and y. That is, we will solve the LPP with the graphical method using the corner point method. So what is the working rule for corner point method? What is the working rule? What is the procedure? How to find out? Let's see. What is the procedure? See. Step 1. First, we have to formulate the given LPP in mathematical. If it is not given, if it is given in the word formation, sentence pattern, the question is given in the sentence pattern, so we have to formulate it to the mathematical formation. Okay. If it is given in the mathematical form, no need to express it in again mathematical. It is already given, so that means with the help of that only we have to solve it. Step 2. In the mathematical formation of LPP, we will get one objective function and some constraints. Okay, the constraints are in inequations. Constraints are in the form of inequations. The inequations are converted into equations. First, we have to convert the inequations into equations. In the equation, on putting y is equal to 0, we will get x coordinate, and x is equal to 0, x coordinate on x axis, and similarly on putting x is equal to 0, we will get y coordinate on y axis. Join these two points, we will get the graph of the equation. Now see, this type of problems already got to draw the graph of a linear equations in two variables from class 9 onwards. We have done same process we have to do. So whatever the inequations are given, to draw the graph of that inequations, first we have to express that inequation into equations, in a linear equations in two variables, and just we have to draw the graph of those linear equations. Okay, and easy process is what? We will put x is equal to 0, then we will get the y coordinate on x axis, and if we put x is equal to 0, then what will get? We will get x coordinate on x axis. Okay, we will get y coordinate on y axis. That is the thing. Step 3. What is the step 3? The inequation of line. So whatever the inequation will get, a graph of the inequation, what will get? Then the inequation of line, divide the planes into two halves. Actually what? When you take the inequations into an equation, and if you draw the graph, then the graph will ultimately, it will be a straight line. That straight line divides the plane into halves. But which half will be satisfy the inequations, that we have to check. Actually what? In class 11 we got the inequalities. That concept are very important here. So if that concept is clear, then it will be easy for us to solve the problem. So same process you have to do. How to solve the inequations graphically, that same process here we will do. Choose the plane of the inequation. We put x is equal to 0, y is equal to 0, that is check with the help of the origin. If origin satisfies the inequation, then the origin containing the region containing the origin. If origin satisfies the inequation, then region will containing the solution will containing the origin, and if it is not, will not, then it will be far from the origin. Okay, it will be away from the origin, it will not containing the origin. So see again, The inequation of a line divide the planes into two halves. To choose the plane of the inequation, we put x is equal to 0, y is equal to 0. In the inequation, if origin satisfies the inequation, then the region containing the origin is the region represented by the given equation. Otherwise, the half plane not containing the origin is the region represented by the given equation. Okay. So that is the process to do. Step 4. What is step 4? The region satisfying all the inequations is the feasible region. Now here we may get 2-3 region, 2-3 halves, and the common half is the known as the common solution of the problem, and that is called the feasible region. Okay, the common region is known as the feasible region. Step 5. The vertices or corner point, whatever the vertices will get of the region, required region, are known as the extreme points of the set of the all feasible solutions of the LPP. Okay, the corner points, that is the point of intersection of the lines, that is called the corner point. Okay, or vertices of the required region are known as the extreme point of the set of all feasible solutions of the LPP. Step 6. What is the step 6? By putting the values of x and y in each corner point. Now we will put the values of x and y of each corner point in the objective function, whatever the objective function we have given. In that objective function, we have to put the values of x and y of each corner point, whatever the corner points we will get. We have to check for each corner point the values of the objective function. Okay, vertices of the feasible region. Out of all these values, the objective function will get a point at which the objective function is optimum. So we will get some points, and out of these points we will get some point at which the objective function is optimum, that is either maximum or minimum. That point we need to find out, and that will be according to the question. Okay, if it is given maximize, we have to find out the maximum value. If it is given the minimize, we have to find out the minimum value. So this is the procedure. Okay, I am going to recall again the procedure. First, what we have to do, formulate the given LPP. Second step is what? The inequations, whatever getting the constraints, that all constraints we have to exchange or express in terms of equations, and we will draw the graph. And next we have to find out the halves, which halves will be the solution for that inequations. For that we will check with the help of the origin. If origin satisfies the inequations, then the region containing the origin is the solution, otherwise it is from the origin. Okay. So next, what we have to do, the region satisfying all the inequations is known as the feasible, the common region is known as the feasible region. Next is what, we have to find out the corner points of the region. Okay, that is extreme points of the set of feasible solutions of the LPP. Next, what we have to do, we have to put the values of x and y of each corner point in the objective function, and according to question which value we need, maximum or minimum value we need according to that we will find out it. Okay, let's see one example. With the help of the example it will be more clear. Here it is given question, minimize z is equal to, this is the objective function, this is objective function, we have to check this one, minimum this z is equal to 13x minus 15y subject to the constraints. These are the constraints, 1, 2, 3, 4 limitations are there. What are the limitations are there? Limitations are x plus y less or equal to 7, twice x minus 3y plus 6 greater or equal to 0, x greater or equal to 0, y greater or equal to 0. These are the limitations. Now, according to the steps we have to move. Let's see the first step. What is the first step? This we have written, minimize z is equal to this is equation number 1, subject to the constant x plus y less or equal to 7, this one, twice x minus 3y plus 6 greater or equal to 0, this number 3, x greater than 0, y greater than 0, this is number 4. For the graph of the first equation number 2, x plus y, we will not draw the graph of the objective function, we will draw the graph of these constraints, these constraints, draw the graph of these constraints. Okay, x plus y less than 7. So for the graph of this, we will draw the graph of x plus y is equal to 7. We are taking the inequation into equation, and we have to make the table. When x is equal to 0, y is equal to 7. When x is equal to y is equal to 0, x is equal to 7. Easy to find out the values of x and y. Okay. Similarly, for the second equation, now for checking, region will be which part? Checking for 0, 0, x equal to 0, y is equal to 0, 0 plus 0, that is x plus y less or equal to 7. Here we will put x equal to 0, y is equal to 0, less or equal to 7, that is 0 less or equal to 7, which is true. That is origin satisfy this. So region will be lies towards the origin, or the region will containing the origin. Okay, that is the thing. Second is twice x minus 3y plus 6 greater or equal to 0. For this we will take the equation twice x minus 3y plus 6 is equal to 0. We are taking this equation. Same process, we will repeat it. X, y, we will find out the points. When x is equal to 0, y is equal to what? Minus 3y is equal to minus 6, so minus minus cancel, y is equal to 2. So when x is equal to 0, y is equal to 2. When y is equal to 0, if we put y is equal to 0, this is 0, twice x is equal to, what will get twice x is equal to minus 6, then what will get x is equal to minus 3. So x is minus 3 comma 0. Now checking for the origin 0 comma 0, we have, here we will put the 0, 2 into 0 minus 3 into 0, so 0 minus 0 plus 6 greater or equal to 0, that is 6 greater or equal to, which is true, it is true. So origin satisfying this, region lies towards the origin, In first case, region also lies towards the origin, in the second case, origin lies towards the origin. Now x comma y greater or equal to 0, it means what? It means the region will be lie in the first quadrant only. X also greater than 0, y is also greater than 0. Now see the graph paper. We can draw this graph in the plain paper also, you can draw this graph in the graph paper also. I am taking the graph paper here. So this is the x-axis, this is drawn x-axis, this is drawn y-axis. So first point is, what are the first point? X is equal to 0, y is equal to 7, and x is equal to 7, y is equal to 0. So x is equal to 7, y is equal to 7, this point, and x is equal to 0, y is equal to 7, this point. Here is 7 comma 0, this is 0 comma 7, and we will draw the line. Okay, we get this line, a straight line for this equation. But here condition is what? The region will satisfy the origin, that means the region lies towards the origin. Region lies towards the origin means what? Which part we have to take? We have to take towards the origin, this part we have to take. Okay, we will not get this part, we will get this part only, containing the origin. Origin is where? Here is the origin, so this part we have to take, this part we have to shade it. Okay, this part. This line divides the plane into halves, one is upper and one is lower. Lower halves will be the solution for this. Clear? But for the second condition, see the second condition, this actually what? We have to take, for the first one is this one, complete. And the second, for the second, what will be the second? Second is twice x plus 3y, twice x plus 3y. Second one is this, twice x plus 3y, twice x minus 3y plus 6 is equal to 0. Points are 0, 2 and minus 3, 0. 0, 2 and minus 3, 0. This is 0, 2. This point is 0, 2. This C 0, 2 and this is minus 3, 0. This point is minus 3, and if we join this line, we will get this line, this straight line. And these straight lines will divide the plane into halves. We will not think about the previous one, just to think about this current one, present one. And this line will be divide the planes into halves, one is upper half, one is lower half, but it satisfy the origin, that means it contains the origin. If it contains the origin, that means what? Which part? This, everything we have to take, this part we have to take, this part. Now what is the common part? Common part is this. And one more thing is that x is greater than 0, y is greater than 0 in the first quadrant only. Whatever the region, it will be lies in the first quadrant only. It will not in the other quadrant, so other quadrant will not take. So this is the common reason, this is the feasible reason for the constraints. Okay, Now what are the corner points? Corner point is this a is equal to 7 comma 0, and this is the point of intersection of these two lines. What is the point of intersection? X is equal to what? This x is equal to 3, y is equal to what? Y is equal to 4, so point is 3 comma 4. This point is C 0 comma 2, and this is the origin. So this is the region, this is the bounded region. Okay, this is the bounded region, and corner points, 4 corner points we are getting. One is 0, origin 0 comma 0, one is A 7 comma 0, one is B 3 comma 4, another is C 0 comma 2. Now we have to find out, see, this is the corner points, these are the corner points, and this is the Z. 0 origin, corner point origin, that is 0, O 0 comma 0, at that point the value of Z is 0, the value of Z is 0, at A is equal to 7 comma 0, if we put A 7 comma 0, x is equal to 7, y is equal to 0, 13 into 7 is 91, 91 minus 0 is 91, b is equal to 3 comma 4, if we put b is x is equal to 3, y is equal to 4, 3 3 is a 3 13 is 39 minus 15 4 is 60, so 39 minus 60 is minus 21. C 0 comma 2, if we put x is equal to 0, y is equal to 2, then what will get? 0, this is 0, this is minus 30, so this is minus 30. Now out of this, the question is given what? Question is related to minimize, that is minimum value. Out of this values, which is the minimum value? Out of this value, which is the minimum? The minus 30 is the minimum value, minus 30 is the minimum value. If it is asked for maximum, then we have to take 91 is the maximum value. So hence minimum value of Z is minus 30. Minimum value of Z is minus 30. At where? At C is equal C 0 comma 2. That means at x is equal to 0, y is equal to 2. So in this we have to solve the LPP, this is linear programming problems. Okay. Hope all of you understand. If any doubt, let me know. I will try to my best to clear the concept. Thank you. Have a nice day.